Okay, last question, and this is the pure maths masquerading as word-based engineering type questions. You've just got to be able to read the question and work out what it's trying to get you to do. So a football pitch measures 30 wide by 60 long. Let's do that. 30 wide by 60 long. If a line is drawn from one corner to the opposite corner, calculate the length of this line and the angle it makes to the short side. Thought I'd worked out how to do it then. Calculate the length of the line. So we've got some Pythagorean theorem here, haven't we? And we also want this angle here. So we can either do it through Pythag. I'm just going to do it through trig. So next to the angle is adjacent, opposite the angle is the opposite. This is the hypotenuse. So I've got an O and an A. Smiles of happiness come after having tankards of ale. Sokotoa, I've got an O and an A, tan theta equals opposite over adjacent. So theta is equal to the inverse tan of two. Don't know why it took me so long to work out there's two lots of 30 and 60. Good job that's captured on video forever. So inverse tan will be shift and tan in your calculator of 2, which is equal to, in this case, 63.43 degrees. We could use Pythagoras theorem. It's a bit more long-winded when we could just use something involving an h. So sine looks good to me. So sine 63.43 is equal to the opposite, 60, over the hypotenuse, which we don't know. So take that up there, that up there. So the hypotenuse is going to be equal to 60 divided by sine 63.43. If you don't know how to do this by this point, just do some Khan Academy and have a good hard look at yourself in the mirror. Right, 60 over sine 63.43. Yeah, I'm not entirely sure why they put this on a level 4 paper. I can only guess that one year they had, maybe on a B-Eng, someone who couldn't do a bit of trig, so they decided to shake it up at the lower levels. 63.08 meters, and we'll just do a quick logic check. I haven't somehow got like 600 degrees and 2 meters. No, it all seems to make sense, so I'm expecting that to check out. If not, I'm going to have my resignation in. 67.1 and 63.4. That's fine, I'll have another day. Right. 5b. This looks a bit trickier. A closed metal cylindrical canister. So this could be an optimization problem, maybe. Has a mean radius r and a length l. Right. Draw a diagram. closed metal cylindrical canister has a radius of r and a length of L. The surface area of the metal used for the cylinder is given by the formula. Let's use the letters that they've got there. We've got A equals 2 pi r squared plus RL. Yeah, stands to reason. Basically it's the circumference, isn't it, times the length. Right. Calculate the radius if area A is 1250 millimeters squared and the length is 20. So I'll multiply this bracket out. L is 20. Oh look, we've got two lots of R. Okay. So this looks like a quadratic formula question. So I'm just going to pause the video and grab the quadratic formula. You'll have it written in your notes. Right, I'll continue from this point here. So we're going to, whenever you see a quadratic equation like this, it's a good idea to write the whole thing set to 0. So by that I mean we'll go 2 pi r squared. Remember, 2 pi is just a number. It's going to be 6.2 something, isn't it? Plus 40 pi r, 40 pi is just a number, minus, I'm taking the minus 1250 over, minus 1250 is equal to 0. And we're trying to work out r, so I suppose in our quadratic formula this becomes r, x just represents the unknown. However, we've got all these a's, b's and c's. I'm going to use a different colour to denote these. So the coefficient of the r squared is the a, the coefficient of the r is the b, and the coefficient of just the term, the coefficient you might say, is c for coefficient. So when we use this formula, we will have a is equal to 2 pi, we'll have b is equal to 40 pi. I could have written those as big long decimals, but no point really. C is equal to minus 1250. It's much easier to put it in your calculator and it's going to save you errors. Right, so let me write my formula down. So R is equal to minus B, which is minus 40 pi, plus minus, so we're going to do this equation twice, one with plus, one with minus, square root of b squared, 40 pi squared, minus 4 times a times c. So minus 4 times a, 2 pi, times c, which is minus 1250. All divided by 2 times a, 2 times 2 pi, so that's 4 pi. Right, I'm going to crunch these numbers as best I can and simplify it, so I'll pause the video a second. So I've done my best with that on my phone. It's a lot easier on a real calculator, but we've got 40 pi plus minus, and I've calculated this horrible thing here to be 217.27, and all that's divided by 4 pi. So in other words, I'm going to do two versions of this equation. We'll call them version A. We'll call it version 1 and version 2. Version 1 is where we're going to have minus 40 pi plus 217.27 divided by 4 pi for the plus, and we do the same again for the negative, so we'll have another version that is 40 pi minus 217.27 divided by 4 pi. So I'm just going to pause the video, crunch those two, plug those numbers into the calculator, and I've got 7.289 and negative 27.289. It expressly tells us to ignore the negative answer. So our solution should be 7.289. That's the radius. Let's check our solutions. 7.3, 7.289, 7.3. There we go, they've rounded. Superb. For the final question, this is probably worth its own little video. You're likely to see a question of this type, so I just want to talk through the logic of it.